We are going to spend a second day taking a look at these story problems that deal with inequalities. If you understood what we did last class, great. That means we should breeze through the assignment for today. You should have no problems with it. If you had questions about it, if you struggled with it a little bit, that's also great because this will give you the opportunity to relearn the material, hopefully, maybe understand it a little bit better. So let's take a look at this one. Again, I'll give you a minute or two to put some of the information in your notes. It says a French club is sponsoring a bake sale at the local farmers market. They sell their pastries for $3.25 each. So they're going to sell pastries for $3.25 each. It says they also receive a $30 donation. And they hope to make at least $220. So they are selling pastries for $3.25 each. They also get a $30 donation from someone, and they want to make at least $220 for the day. We are asked to set up and solve an inequality to find the minimum number of pastries they must sell. We're going to start this again with words and then transform that into an algebraic inequality that we can solve. So it starts with saying they want to make at least $220. So money earned or money made or something like that. We are going to compare that with 220. And we want to think about which of these we want to be bigger, or at least the French club wants to be bigger. So dollars earned, 220. They want to earn at least $220 for the day, so they want their money earned to be bigger than 220. At least means it could also be equal to 220. And now we're going to set up our algebraic expression for money earned. So we want to think about what things do they make money on. It says they sell their pastries for $3.25 each. So each pastry they sell, they're getting $3.25. So they're earning that $3.25, not just once or twice, but every time they sell a pastry. And we don't know how many pastries they sell. So that 3.25, we're going to multiply that by x, where x is the number of pastries sold. So if they sell 10 pastries, we would do 3.25 times 10 would tell us how much money they make selling their pastries. If they sell 100, we do 3.25 times 100. We don't know how many pastries there are, so we use a variable x. Plus, they also make money because this one customer donated $30. That $30, they just got that once. So we do not include an x next to the 30 because they're not getting $30 for every pastry that they sell. They just earn that $30 one time. That is everything they earn money on. We have completed our expression for money earned, so we can fill in our inequality. 3.25x plus 30 needs to be greater than or equal to 220. From here, we can solve our inequality. Subtract 30 from both sides. These cancel. I get 190. I bring down my 3.25 x, sorry, 3.25x, that's important. This means 3.25 times x. We undo multiplication by dividing. We divided by a positive number. We don't flip our inequality around. This would for sure be a calculator problem. We have 190 divided by 3.25. I get 58.462. So we have written an inequality. We did that here. We solved our inequality. We did that here. And now we need to find the minimum number of pastries they must sell. This is saying that X, which is the number of pastries they must sell, has to be greater than or equal to 58.462. Well, it can't be equal to 58.462. You can't sell 0.462 of a pastry. So they either need to sell 58 or 59. Notice X, the number of pastries they sell, needs to be bigger than 58.4. 58 is not bigger than 58.4, but 59 is. They need to sell at least 59 pastries. Let's go ahead and take a look at example 2. This one's a little different. It says the sum of a number and 81, is greater than the product of negative 3 and the number. The sum of 81 and a number, the sum of a number and 81 is greater than the product of negative 3 and the number. Thinking back way to Unit 1, what we covered way back in August, the word sum means we're adding. So we're adding a number and 81. We don't know what that number is, so let's call it a variable. We typically use X. I'm going to use N this time. So the sum of a number and 81. So sum means add, N and 81, is greater than, bigger than, I need this side to be bigger. The product, the word product means we need to multiply. Negative 3 and the number. Notice it's the same number that we had up here. So if I call this one N, I need to call this number N as well. We were asked to write and solve an inequality to show all possible values of the number. We wrote the inequality. It's right there. Now we need to solve it. We have n's on both sides. When I have a variable on both sides, I need to move all the variables to the same side of my inequality. We can do that either by subtracting n from both sides or adding 3n to both sides. I am going to add 3n to both sides. And these cancel. Negative 3n plus 3n cancels. I don't have anything over here. That's 0. 1n and 3n make 4n. Subtract 81 from both sides. I get 4n is greater than negative 81, and divide both sides by 4. N is greater than negative 81 over 4. It doesn't say we have to have a whole number like we did when n represented the number of pastries. This is a fine answer. If you want to type that into your calculator and say n is greater than negative 20.25, that's fine. That is a fine answer. Either of those are acceptable. Example 3 says Jerry is shopping for clothes. He has $70 he can spend. He bought himself a belt for $22, a shirt for $17, and he wants to spend the rest of his money on hats. Hats cost $8.50 each. We need to set up and solve an inequality that's going to help us figure out the maximum number of hats that he can purchase. So again, let's start with words here. says he's shopping for clothes. Actually, let's highlight the things you should probably get in your notes here. Jerry has $70 he can spend. He bought a belt for $22, a shirt for $17, and the rest on hats. Hats cost $8.50 each. We need to know what is the maximum number of hats he can purchase. Again, we're going to start out in words here. It looks like Jerry is spending money. So money spent. And we need to compare that to $70. That's everything he brought. Again, we want to think about which side needs to be bigger. Well, dollars spent can't be bigger. He can't spend more than the $70 he brought. So the 70 has to be bigger. Or he could spend all $70. So the amount of money he spends has to be less than or equal to 70. And now we want to start filling things in for money he spent. It says he bought a belt for $22. He bought that one time. He just bought one belt, so it does not have an X next to it. He bought a shirt for $17. Again, he just bought one shirt, so 17 just one time. And he's going to buy multiple hats. He's going to spend $8.50 on each hat. So because it's each hat, he's spending that $8.50 over and over again based on the number of hats he sells. So $8.50 per hat, where X is the number of hats that he buys. So he spent $22 once, $17 once, and $8.50 per hat. So $8.50X, where X is the number of hats that he buys. There's our inequality. Now we solve it. 22 and 17 are on the same side. Those are like terms. We just combine them. Subtract 39 from both sides. And divide both sides by 8.50. I get 3.647. X has to be less than or equal to 3.647. If he buys 4 hats, that's too many. He doesn't have enough money to buy 4 hats. So the most number of hats he can buy is 3. Last one. This one says that an elevator can safely lift 4,300 pounds. You are transporting concrete bricks that weigh 22 pounds each. It says you weigh 180 pounds. You're going to get in the elevator with all these bricks. The question wants to know, what is the maximum number of bricks you can safely bring? So you're loading up all these bricks, you're transporting them in this elevator. You need to ride in the elevator with the bricks. You weigh 180 pounds. The bricks weigh 22 pounds each. We need to know what is the most number of bricks that you can bring in the elevator to stay under that 4,300 pound limit? This time, the thing that we are comparing, we are looking at total weight, the total amount of weight we put on the elevator, and we are comparing that to the 4,300 pound weight limit. Now you want to think about which of these needs to be bigger. Well, we don't want the total weight to be bigger than the 4,300. 4,300 needs to be bigger. Technically, it says it can safely lift 4,300 pounds. I don't know if I want to be exactly at the weight limit. Let's say the weight has to be less than 4,300 pounds. If you put an or equal to sign under there, that's fine. I would understand that. Now we want to think about things that are going on the elevator that are going to increase the weight. It says that you are getting on the elevator and you weigh 180 pounds. So when you get on the elevator, that adds 180 pounds to the weight. But there's just one of you that's getting on at 180 pounds. So we just add that 180 one time. Plus you're going to put a whole bunch of bricks on this elevator. We don't know how many bricks that we're going to put on. Let's call X the number of bricks. And each one weighs 22 pounds. So the weight added due to bricks is 22 pounds times the number of bricks that we add. We can solve our inequality. Subtract 180 from both sides. Gives us 4120. Divide both sides by 22. Gives us X is less than 187.27. We want to know what is the maximum number of concrete bricks you can safely bring. It says it can safely lift 4,300 pounds. We have X has to be smaller than 187. The first integer that is smaller than 187 is, or 187.27, is 187. So 187 is the most number of bricks you can bring to stay under that safety limit of 4,300 pounds. You might want to bring less than that, though. We don't want to get close to the safety limit. I'd probably bring about 150, but 187 is the most you can bring.